Hello guys, I'm going to show a short demo for our project for the course of Advanced Computer Network Security. The title of our project is Software Defined Network Based Firewall. The teammates are Bhuvana, Ashwin and Swati. The firewall has the following functionalities: permit deny packets based on protocol, permit deny packets based on layer 4 addresses, permit deny packets based on layer 3 addresses, permit deny packets based on layer 2 addresses. A small gist of the entire implementation. This implementation pushes the flows using RESTconf. It's a REST-like protocol running over HTTP for accessing data defined in YARN using data stores defined in netconf. RESTconf allows access to data stores locating in controller. There are two data stores. Each request must start with URI/RESTconf. Config data store contains data inserted via controller. Operational data store contains data inserted via network. The RESTconf protocol operates on a conceptual data store defined with the YARN data modeling language. RESTconf supports options get, put, post, delete operations, just like any operations over HTTP. Request and response data can be in XML or JSON format. XML has structure according to YARN by XML YARN and JSON by JSON YARN. The topology that we are going to follow is a tree-like topology with four hosts: host 1, host 2, host 3, and host 4, with three switches: host 1, host 2 connected to switch 2, host 3, host 4 connected to switch 3, with an intermediate switch, switch 1. It's a tree-like topology. I'll be demonstrating a couple of flows, sample flows, based on their layer 2, layer 3, and layer 4 addresses. So using Mininet, first I check whether all communications are happening properly. Yes, the entire communication is happening properly. We are able to ping all of them. So let's look at some of the sample flows. The first flow we'll be looking into is based on layer 2 addresses. Let me explain some of the points in the XML flow. The two main headings of this entire XML flow are instructions and match. In the instruction field, you have to specify an action which the switch will execute once a match is found on any incoming packet. The matches are specified in the match subsection, and the instruction, like the actions, are specified under the instructions heading. The instruction which I have given is drop action. For the match part, we want the flow to match on Ethernet addresses, that is layer 2 addresses. So the Ethernet type I have specified is 2048 decimal representation of 0800 hex for IPv4 packets. Ethernet source, this is the Ethernet address for host 1, and Ethernet destination is this is the MAC address of the host 4. Some couple other headers include hard timeout, idle timeout, which indicates how long the flow has to remain in the switch before it is purged out by the switch automatically. I've set it to 0, which means I have to manually push it out. Otherwise, this flow will remain in the switch forever. Cookie values, it's an open flow way of identifying each of the flow uniquely. Flow name, priority. Priority specifies the precedence. Like if there are multiple flows which are matching on a particular packet, the flow with a higher priority will take precedence. Now I push this flow, I get a response 200 OK. I go back and check whether I can see the flow in the switch. There we can see our flow with the source MAC address and the destination MAC address. The action is drop. Now we go back to the Mininet console and try to ping and see what all connections happen. You can see that we were able to successfully ping from H1 to H2 and H1 to H3, but the ping from H1 to H4 will fail because of the flow added on switch S1. See, the flow failed, the ping failed. Similarly, the ping from H4 to H1 will also fail because ping involves ICMP echo and response, so the response fails because of the flow. Now we'll move on to the flows involving layer 3 addresses. Before that, I will delete the flows which I have already added. We'll move on to the flow involving layer 3 addresses. Again, the instructions would remain the same, the drop action. However, the match would change I have removed the Ethernet source and Ethernet destination and added IPv4 source and IPv4 destination, trying to block communication between host 1 and host 4. Rest all headers remain the same. I push this flow. I go and check the flow on the switch. I see that the flow has been added. Network source, network destination drop. I go and check in the mininet whether the flow is working properly. Again, the ping from host 1 to host 4 will fail because of the flow added, which matches on layer 3 address. The ping from host 1 to host 4 has failed. Similarly, ping from host 4 to host 1 will also fail because of the ICMP echo response being blocked. Now let's move on to layer 4 addresses. Before that, I'll delete the flows which I've already added. I deleted it. Now I'll go and add a flow based on layer 4 address. The other things remain the same. I've removed Ethernet source destination, IPv4 source destination I've removed. I've added Ethernet type 2048, which is for IPv4 packet, IP match on protocol 6, which is TCP, and TCP destination port 80. What this means is I want to block all communications with the packet having TCP destination 80 on this switch. So that means all communication trying to happen from this side to this side with TCP destination 80 will be blocked here. So if I try to connect host H1 to host H4, if a server is running on H4, then it will be blocked here. But TCP communications on this side will work, like TCP communication between H1 and H2. Let's go and check that. I will need 3 external consoles, extern H1, extern H2, extern H4. Let's run a TCP server, node H4, and try to connect to that server. It will fail because of our flow. I think I did not push the flow. I need to push the flow. Now I push the flow. Okay, and the server is listening. See, there is no response here. So that means that the packets were blocked on the switch S1. Now if you try to communicate between host 1 and host 2 with host 2 listening, and if I do an echo from here, there you go. I see a response here. So that simply means the communication, the TCP communication between host H1 and H4 was blocked at switch S1, and TCP communication between H1 and H2 works because it does not involve a path via S1. So that's all. These were the 3 sample flows which I demonstrated. I think that pretty much explains all. Thanks for watching my video.